So guys, today's question is minimum operations to make a binary array element equals to 1. Okay, so what the question is about? You're given a binary array and it named nums. You can ask me what's a binary array. And the binary array contains only 0 or 1. You can do the following operations on the array any number of times, possibly 0 also. Choose any 3 consecutive elements from the array and flip all of them. Flipping an element means changing its value from 0 to 1 or 1 to 0. Return the minimum number of operations required to make all elements in the nums equals to 1. If it is impossible, return minus 1. So for an operation, you will choose 3 consecutive elements and flip it into 0. I mean flip it, not into 0. See this array, at first chosen the 3 elements. 0, 1, 1. When he flipped it, it became 1, 0, 0. And then he chose the next 3, it became 1, 1, 0. And the next 3, 1, 1, 1. What's this about? 1, 0, 0. 1, 1, 0. This can't be done. So we need to make, let's start the timer. We need to make a perspective so that by flipping this, we'll get 1. So see this. 0, 1, 1, 1, 0. Then we use sliding window here. What pattern does this question fall into? Let's try to figure out that one. We're taking consecutive elements and we're flipping, and taking another 3 consecutive elements, then again flipping, next another 3 consecutive elements, again flipping. So how many consecutive elements can we take? Okay, so for an iteration, we can take the first 3, the next 3. So the thing is, we can check by taking the iterations. If the elements result in 1, 1, 1, then the resulting array will be all ones. So we can directly make this happen like this. For I equals to 0, I less than n, I plus nums dot length. Okay, we're doing a loop. How many times are we iterating in the loop? Hmm, First thing would be from 0, 1, 1. After every 3 elements, we push the pointers, right? So we start and it should be end. So this is a typical example of a sliding window problem. Let's take start and end pointers. Each start equals to 0, end equals to 2. What if the array length is less than 3? Is there any constraint like that? No, array length greater than equals to 3. So we can take this. There is no edge case here. So N equals 2. It's the initial case. So 0, 1, 2. Hmm. Now, what do we need to do is, okay, it will be big of n square solution. Since flip this, while n less than nums dot length for in I equals to star I less than equals to n I plus plus. You need to flip the bit, right? If nums of I equals to 0, nums of I equals to 1. Nums of I equals to 0. Okay, we're done with the flipping. And what do we need to do? We need to update the start point, start plus plus and and plus plus. So what happens? By the end of this loop, by the end of this loop, the array gets flipped. So if the array gets flipped, we need to do one thing. We need to check whether it's all one or not. Minimum number of operations required to make all the elements in the nums equals to 1. Oh God, this like minimum number of operations I need to make. It's an optimizing problem. Looks like binary search and answers, but no, I don't think so. Because if we consider minimum operations as how many we can take? The minimum possible operations are one. Sorry, the maximum operations are one. Here, if we consider here one, two, three, and four. Okay, the minimum number of here it is four, but we only took three. I guess this is not an approach. Not an approach either. I feel like it is. What could be the pattern here? If you don't know what the pattern is, let's look at the hints. Nums of 0 is 0. The only way to change it to 1 is doing an operation on the first elements. After changing, use the same logic on the remainder. Don't get it basically, but the only logic is if we can able to flip this and these two are good to go. One zero zero at first flip, 110 in the second flip. Mm, should flip all of them, not one of them. The best thing I can do is It's not binary search or answers. The maximum number of operations we do here are 4. But why did we take 3? Okay, let's come from the hints. If we figure out 0, the next 3 elements are flipped. Okay, let's write a for loop for int I equals to 0, I less than nums dot beyond the equals I plus plus. If you figure out a 0, okay, nums of I equals to 0, then you need to flip, flip, flip of nums of flip of I comma nums. And after you flip, you do count plus plus. And count equals to 0. Link static void link in I comma in nums. How we gonna flip? Going to write a for loop for in I equals to 0. Sorry, in I equals to 0. I less than equals to k here, right? K plus 3. K plus 1, k plus 2. K plus 2. I plus plus is 0 um, uh, 0. Where the logic for flip and if a 0 occurs, flipping it. Okay, here a 0 occurred, where then went for flipping. Let's take this like this. 1 0 0 1 0 1 1 1 0 0. First this 0 occurred. We did a flip operation. It becomes 1 0 0 1 0 0. And then again we got next 0 here. So we do a flip operation which results us in 1 1 1 0 0 0. And again we do a flip operation here which results in this. So after this array 0 1 1 1 1. We see a 0, we do a flip operation which will result in 1, 0, 0. We see a 0 again, we do a flip operation, it will be 1, 1, 0. And we see a 0 here, but we can't make a flip operation. If the 0 is like this, okay, we need to check only till -3 because that's At max, you can check 1, 2, 3, 4, 5, 6. 6 minus 3 is 3, 0, 1, 2, 3. Yeah. Oh God, I haven't returned anything. Return, um, I don't think it will give us minimum. Making a flip operation doesn't count. After, if the array is all -1, then only we gonna take this. We make a flip operation once, and then we make a flip operation again. It's 2. Return count plus 1 here. Let's do one thing. If nums, okay, we can do nothing else. We need to use a for loop. Int product equals to 0 for in value of nums. Multiplication equals to I. If product is 0, return -1. How so? Let's debug this. Mm, 1, 1, 1, 0, 0, 0. This one. Oh God, it got accepted. It's great. No, it's accepted, guys. Let me see the topics it was given on. Requirement question, queue, sliding window, prefix sum. Okay, these are the topics that were given. Okay, now let's look at the editorial. Given a binary array, I don't know what using these two. The first observation is if a zero appears, then the end of the array, specifically within the last two positions, we cannot flip it using full triplet. This means that any zero is left in the last two places after crossing. It's impossible to make the entire array 1, so we return -1. Since the solution operation affects three elements, each flip we apply has lasting effect on the next two indices. Instead of modeling the entire array and recomputing the values every time, we need a way to keep track of the flips already applied. Okay. We have used a queue here. Mm-hmm. It is big of an sliding window. Mm-hmm. Other tag, it pronouns from second, starting from second element. Implementation in place algorithms. In place algorithms modify input directly to fail play, but they can sometimes cause issues. These are the times when there are times when in place approach isn't the best idea, like however searching multi-thread environment or exclusive access to array. Other threads might need to read an order to change. Deployment placement is really and if that's the first step fire several specific tactical info operations. Specifically check the path on this for anything. Whether our number this is no number of clicks in our day. We serve as our base cases. We require three base cases because our induction step will rely on the fact that m greater than or equal to say and -3 greater than or equals to. This ensures that our inductive reasoning applies properly. Inductive hypothesis. Wait, oh God, it is taking mathematical induction here. Uh, Time is, let's see, yeah, I wrote an optimal code. Good with this. Suggest solving everything not solving what's not is to one. The general case. Mhm. Sliding window technique is often useful of sure. Yeah, that's true. Gain much, but only should do choice. Sure. That's it, guys, for today. Thank you for watching.